Okay, so today we're looking at antiderivatives. So our learning intention is to be able to calculate the antiderivative function. So it's important that you are able to calculate the antiderivative of dy over dx equals x to the power of n. The antiderivative of dy over dx equals ax plus b to all to the power of n, and know the general chain rule. Okay. So these are what you would see on your formula sheet. Okay, dy over dx equals xn. Then, these are not what you'll see in the formula sheet. There's another one I'm going to show you, but these are just the rules. So if you've got x to the power of n, you're going to divide the coefficient by 1 over n plus 1. So you're going to raise the power and divide by that number, and then raise x to the power of n plus 1. If you have a constant, you're going to if you just have a constant, so the antiderivative of that is the constant with an x. If you have a constant x of n, well, you're going to divide that constant of k by n plus 1, a higher power, multiply by x with n plus 1. Notice that we have the plus c, so that's where c is that constant. We need a constant, because when you were to differentiate, that constant disappears, so we don't know where it is, so we need that constant to set it. So if we want to find the primitive function of x to the power of 3, so, I raise the power and I divide by that number, plus c. Okay. So here I'm going to raise the power, so that 3 becomes a 4. I can divide the coefficient by that number. So really it works out to be a half x to the power of 4 plus c. And obviously we should be able to differentiate this and get the same thing. So 4 times a half is 2. That's 2x cubed plus 2x cubed. That c disappears, that constant disappears. Okay. So what I'll do with this one, before I find the antiderivative, I'm going to write it in index laws. Okay, so x squared, so 1 over x squared is the same as writing x to the power of negative 2. So I'm going to raise the power and then divide by the power. And rewriting this gives us negative x to the power of 1, which is to the power of negative 1, sorry. So that's that, plus c. Okay. If I was to differentiate that, negative 1, bring that down, becomes positive 1, drop the power, so x negative 2. That's correct. So same thing here. I'm going to write it as x to the power of negative a half. So I'm going to raise that power. That becomes x to the power of a half. So I'm adding 1 to it. So 2 divided by a half, maybe I should write that down. 2 divided by a half gives you 4 x to the power of a half plus c. Okay. Always try to provide your solution in the same format as they provide it to you in the question. Alright. So this is what you would find in your formula sheet. If you have dy of dx equals ax plus b all to the power of n, then y equals 1 over a n plus 1 ax plus b n all to the power of n plus 1 plus c. Now n can't equal negative 1. Okay. So using this kind of formula, find the antiderivative of y. So that should be dy over dx equals that. Okay, so using this idea, we're going to use this formula. So y equals 1 over, the a is 4, the n plus 1, so that's 3 times 4, or 3 plus 1 is 4, of your ax plus b, and then that becomes to the power of 4. So we get 1 over 16, 4x plus 1 to the power of 4 plus c, using that formula. Alright. Now this is what you find on your formula sheet, the general chain rule. If you want to integrate f dash of x multiplied by the function of f of x to the power of n, that's 1 over n plus 1, f of x, n plus 1 plus c. Okay, so for example, I'm going to let this be f of x. So f of x is 3x squared plus 7. The derivative of that is 6x. So this is in the form of f dash of x multiplied by f of x to the power of n. So the derivative, the antiderivative, is going to be 1 over 5 times by this whole thing, and 4 plus the n plus 1, which is 4 plus 1 is 5, plus c. Okay. Let's try this one. So I'm going to let the inside be f of x. That is 3x to the power of 5 plus 2. The derivative of that is 15x to the power of 4 plus 2. So that's not plus 2. 15x to the power of 4, which is very similar to this, right? So we're just missing a factor of 15. So we could we can accommodate that by taking out 1/15 out. And that means you'd then get, right, this idea. So 1 lots of n plus 1, so n is 3, so 3 plus 1 is 4, times by the function n plus 1 is 3, and then plus c. Cleaning this up, we get 15 times 4 is 60, 3x to the power of 5 plus 2, so that should be 4. Yep. Plus c. Okay. And that's it. Have good luck.